So this is really intended kind of be a brief history of the utility infrastructure for the borough and some interim steps that happened and kind of where we're going with Point Lake currently. I'll skip through a couple of these here. And going through this, it'll kind of ring back to Ives's conversation this morning about utilities. It's kind of seemed like he should have had this slide deck. And then what Yuri and Billy have talked about as well. So this is Point Lake for those who haven't really seen it. It's a little more expansive view on the left side. You can kind of see where the drained lake is that Billy alluded to earlier. The whole reason I wanted to include this here is Point Lake again shows all the different signs of permafrost. We've got the high centered polygons here. We've got more low centered polygons here. We're kind of chasing all the conditions across the community. And then again, we've got known ponds that have been forming for a number of years and continue to grow dramatically. Local conditions, I mean, it's winter, and it's harsh when it's winter, but in the summer, we have some really unexpected conditions. We've got the damming that the road structures have created in the community. So now we have a lot of latent heat that keeps building up on the permafrost annually. That has to get either cleared out of the community by clearing culverts, or we have to pump it across roads. For those who haven't seen it yet, or going to see it tomorrow or Monday night, this is what the Utiqiagvik system looks like. There used to be an old mock-up near the A block that was discussed earlier, where you could actually go see this and not have to get into the actual Utiqiagvik structure itself. And then the direct bury systems, this is really what those look like. We're putting Arctic pipe in the ground. If you're not familiar with the Arctic pipe, we've got our core pipe, HDPE, and then we've got an insulated layer with a jacket to protect the whole system. So current conditions, this is kind of a mix. We've got a lot of settlement issues. We've got settlement next to buildings. We've got settlement in the streets. They're all tied to larger excavations. We'll go into that here in a little bit, but it's creating issues that we have to have a lot of construction effort and expense put to maintain our systems. One thing that the engineers didn't plan for very well early on was corrosion. Even though we're going to keep a thawed system right next to our flanges and bolts underground, and after 10 years, we're seeing quite a bit of material loss, and Barrow's got a lot of unmet need in that regard. Water leaks, that's what gets everyone's attention. We start losing water out of our limited water supply. We have fill and draw systems. We pump water annually, store it for winter use, and then the next year we go to make more. So every time we have a water leak like this, it gets everyone's attention real fast because it puts pressure on the water supply, and there's a risk of running out. The water leaks also create hidden damage. We have 60 psi water, and the spray foam that's in the pipe is rated about 35 psi. And when we have an underground water leak, we get the insulation crushed, and that creates a problem for our operations for risking freeze up underground. And this is one of these Arctic pipes here, and this wrinkle is a place where, just like this, we've lost insulation thickness. So this is maybe an inch of depression in the Arctic pipe wall. Just like this picture here, we've lost about an inch around here, and then the jacketing is kind of folded up, so it looks like it's wider on that side. And this is kind of a bigger one with more wide-ranging issues, inflow and infiltration into the collection systems. It's a problem at our wastewater plants because it taxes our ability to process wastewater during the May, June months and stretching into July. But more to the point, it also shows that when the water and sewer systems were installed, the trenches that they put the pipe in are more permeable than the original permafrost, creating a groundwater channel that surface waters can flow through, meaning that now at the bottom of our trenches that are 10 to 14 feet deep, we have thawed conditions in May. All right, so something that I've talked about earlier is settlement in our systems. A big component of this is areas where we have large excavations, such as a manhole. We'd have a place where a person can get into the ground and work next to the manhole to connect pipe. Problem is that creates a condition that now we can have excess settlement in that area around the manhole. A part of the problem there is using frozen soils for backfill. We get about 65% compaction on those soils. So after the first thaw season, we start seeing consolidation of those areas and the pipes descend through the trench. Similarly, we might see something in the field on the pipe where a service connection or a clean out exists, and we'll have the same condition. All right, so this is a sewer camera profile, record drawing for Summer Street in Wainwright. So always a good example. The red lines on the profile here show the sewer camera positioning. So we've seen over 8 years of service, 2, 3, 4, 5 feet of settlement. And I guess this picture doesn't show very well, but this is the same street. And this stretch right here, we over 50 feet, we had a 5-foot deflection. So what the borough's done over the years to address some of these issues, we've had some programmed responses. This is point lay. We went to more of a shallow bury installation, keeping the utilities as much in the road prism as possible, trying to keep it out of the permafrost. And that's been mostly successful. The main places we've had issues are where we've had a service tee go off and it would tie into an original deeper service. And that's where our weak link has moved. We've had more repairs, and as talked about with Ives earlier, using spray foam. That's done a few things for us. It gives us a water barrier, acts as a trench plug, gives us a larger footing and more insulation value for the permafrost in that area. We did do some tests early on when we first started doing this, and we're getting about 90%, 97% recovery of the insulation that the manufacturer is expecting when we use this product. All right, so we're kind of moving into interim, possibly long-term solutions. Right now, Point Lay's got every home except for one now has a holding tank, and all the commercial industrial facilities are still on the pipe system. So there's not much not much demand left on the piped collection system at this point in time. But the borough's still having to invest a lot of capital to make this happen, because the other alternatives, we go way back and we go back to honey bucket service, which that doesn't do anyone any service, any benefits for health, and no one wants to see that. Okay, so going forward, this is kind of what we're looking at for revisioning Point Lay, new above grade water and sewer systems. Still a circulating water main, so still a single loop, much like what they have currently. The sewer collection system is proposed as a vacuum system. There'll be a couple sub loops, one here, and then there'll be a smaller one for the industrial area. Got a couple mock-ups, renderings for a couple homes for what connections in the community would look like. Any of the above grade systems, if you've seen them elsewhere in the state, really it winds up being fencing in the yards in some manner. You're going to block off access, whether it's pedestrian, snow machine, ATV. So we tried to give the community an idea what that might look like, because it's going to be a very large change for them. Just commentary while we're here. So we've got our mainline service piping here. We've got a utility feature, a connection box outside the home. One thing that still needs to be addressed is what disconnection between the connection box and the home looks like. Because with all the ground movement, we need to make sure that connection is very flexible to account for any changes there. Just mock-ups of what we're looking at currently for pipe supports. We've got thermopiles for the pipes out in the field, And then this is more envisioned as a tall pipe support in the industrial area, so traffic can go underneath it. One challenge, and we'll highlight this here and on the next slide as well, is road crossings. We do have a number of road crossings that we're going to need to make through the town. We don't like the idea of going buried through the road, but we're not seeing a whole lot of options at this point in time. So those are having to be reinforced, heavily insulated, protected thermally with the thermal siphons, just to keep those areas stabilized. And there's more challenges related to that here. So we need to do these in not just road crossings, which might be Main Street or back street, but we have to do these on the east-west road crossings as well, because of their snow push areas that we need to make sure Public Works still has their access through to service the community. Thank you. The other challenge is setting piling for these new service mains. We have to either dictate where these locations are going to be for a contractor so that we can avoid these ice wedges that have been talked about, or we're going to have the piling go down to below sea level effectively to keep stability. All right, so that's kind of where we are with those systems.